Welcome to video 13 of Gamer to Game Developer Series 1, and in this video we'll implement player energy. So we've got a couple of objectives. The first one is to write the player energy script. So this script will regulate the player's energy. Then we'll actually make that energy bar texture, really simple texture. We'll update our stat display script so that it'll now show an energy bar on the HUD. And then we'll update the Fire Blaster and Blink scripts so that they account for energy. When we use them, they'll use up the energy. So just briefly, let's have a look at the system itself. So the player energy script itself will regulate how much energy the player has and how quickly their energy recharges over time. And it's their stat display script, as you remember, that draws the health bar. So it will update it so that it now draws the energy bar as well. And the stat display script will be looking at the player energy script to see what the player's energy level is. So whenever the Fire Blaster and Blink scripts run and the player has fired a weapon or they've blinked, then some of that energy is used up in the player energy script, and the stat display script will see that and then reflect that change in the HUD, so the energy bar would decrease. And the player energy script will also recharge the player's energy over time. So when the player's not using their energy, it'll recharge over time. So our very first step will be to write the player energy script. Alright, let's create a new script, a new C# script, and call it player energy. And of course, let's open it up in MonoDevelop. Okay, I'll type out the summary. And quite simply, I'll just write that this script is attached to the player and it governs their energy. This script is attached to the player and it governs their energy. Then we'll have just a few variables, and as usual, we'll just copy this bit here. So the first one will be public float energy, public float base energy, which I'll set to 100, and private float recharge rate, which is equal to 20. Alright, and that's it for our variables. Then we'll jump over to the start function, and if network view.isMine is true, then I'll set the energy to equal the base energy. So it'll start at the base energy. Alright, now else enabled is equal to false. Okay, and that does it for our start function. So now we can jump over to the update function. So I'll write here the comment, if the player's energy falls below their base energy, then start recharging it. So if the player's energy falls below their base energy, then start recharging it. So if energy less than base energy, so if it's less than base energy, then energy is equal to energy plus recharge rate times time dot delta time. And that's it. That's pretty simple. Okay, And now the next one is, will prevent the player's energy from exceeding the base energy or falling below 0. So I'll write that comment. Prevent the player's energy from exceeding the base energy or falling below 0. So if energy is greater than base energy, then energy is equal to base energy. So just set it back down to the base energy if it's gone up. And it can go up if the player picks up a recharge pickup, which we'll implement later on. So when that happens, quite simply their energy is just brought back down to the base energy. Alright, now the other condition. If energy is less than 0, then energy is equal to 0. So I don't let it go below 0. For example, when the player uses a weapon of some sort, or they're using blinking and somehow the energy just subtracts and becomes less than 0. If that were to happen, then just set their energy to 0. Alright, and that does it for our player energy script. That's all that we need in there. So let's save it and jump over to Unity and just check that there are no errors. And it looks alright, which is good. Alright, so that means we can move on to our next step, which is to create the energy bar texture. Our second step will be to create the energy bar texture. Alright, so I've opened up the GIMP and I'll create a new texture. So new, and the width will be 128 and the height 16 pixels. I'll just hit OK. Alright, and now I'll add an alpha channel. So I'll go to Layer, Transparency, Add Alpha Channel. And I'll clear the background. So Edit, Clear. Alright, so now it's a transparent background. So now I'll go ahead for our forecolor. I'll change the color to a nice blue color. So I've already determined that what I want is an R143. G, the green color, will be 213. And the blue color 255. Alright, so that's the blue color I want for the forecolor. So I'll click OK. Now I'll select the background color and I'll click that blue color and now just pick a darker shade of it. So I can just go around, have a look. Yeah, okay, I'll take this color right at the top so it's much darker blue. Hit OK. Okay, so that's our colors set up. Now I'll select the gradient tool and I'll change the opacity to 80%. And it looks like to me the gradient is going to be drawn the way I want it, with the light side on the left side. So let's give it a shot. Let's draw it. And yeah, that looks nice. Alright, so now I'll just save it. So File, Save As, go to my Asset, Textures, and I'll save it as Energy Bar .png. And yes, keep all those settings. And let's go over to Unity. And we should find our new texture. Alright, so there it is. Okay, so that completes this step. Now we can go and edit the stat display script so that it actually displays the energy bar. We're on to our third step, which is to update the stat display script so that it now shows the energy bar. I've opened up the stat display script, so the very first thing is we'll add a new bit of commentary that this script accesses the player energy script. So this script accesses the player energy script. Alright, and then we'll add a new slot for the energy bar texture. So I'll write down here, so a new variable. I'll first give that comment. The energy bar texture is attached to this in the inspector. So the energy bar texture is attached to this in the inspector. So public texture energy text. Okay. Now below this bit that's for the health, where it's used in calculating and displaying the health. So now we'll have two variables for displaying the energy. So used in displaying energy. And they are private float energy, private int energy for display. Okay, now for defining the stat display box. So we have two new variables now as well. So just below this bit where we define the health bar length and the health bar height, we'll add in two new variables for the energy bar. So private float energy bar length, private float, well, private int energy bar height, which is equal to 15. Then we'll add a new GUI style. So private GUI style, and it'll be called energy style, is equal to a new GUI style. Okay, and now coming down the bit where it says a quick reference to the health and damage script. So now I'll just replace that, a quick reference. I'll just say quick references. So I'll change this comment. And we'll now have private player energy script. Okay, so that's it for our variables. Now we'll come over to the start function and we'll access the player energy script. So right here, where we're busy accessing the health and damage script, we'll now access, so I'll write here in the comment, access the health and damage and player energy script, and player energy script. And quite simply, energy script is going to equal game object dot get component, and that component is player energy. Alright, now let's set the GUI style. So we now have energy style dot normal dot text color is equal to color dot cyan. Then we'll have energy style dot font style is equal to font style dot bold. Alright, so that's our start function done. Now let's go over to the update function. Now we need to calculate the energy bar length. So we'll have a whole bit of new code here in the update function. So what we'll do is to first access the player energy script continuously and retrieve the player's current energy. So access the player energy script continuously and retrieve the player's current energy. So energy is equal to energy script dot energy. Next, we'll round the energy value so there aren't any decimals. That's the one that we'll use for displaying in the HUD. So round the energy value so there aren't any decimals. Energy for display is equal to mathf dot seal to int, and that value is energy, because that's the float that we need to convert to an int without any decimal places. Okay, so now we should calculate how long the energy bar should be. So calculate how long the energy bar should be. So energy bar length is equal to energy divided by energy script dot base energy times 100. And if you just did that calculation yourself, you'll see that's simply a way to measure. It's pretty much the percentage of energy remaining is what we're calculating there. Okay, so that's it for our update function. Now that we've calculated the energy bar length and we've also captured the energy for display, so the energy value without any decimals, we need to display it on the HUD, and that's done in the onGUI function. So I'll now write a new comment here in our onGUI function that draw the energy bar and make its length be dependent on the player's current energy. So draw the energy bar. Or actually I have a better idea. How about we just copy paste this existing health bar code. So copy, and we'll just edit it. Paste. So I'll write here, draw a plain box behind the energy bar. I'll just put more gap there so it's really apparent that they're different. So GUI.box, new rect, common left, so the left will stay the same. We want their alignment to be the same, but the top needs to change. So this should be lower than the health bar. So it'll now be common top. Oh, actually, no, we don't want this one as well. This is the wrong one to draw. This box is the bigger box inside which all the other bars sit inside. So we're going to start from here. So draw a gray box behind the energy bar. That is GUI.box, yes, common left plus padding, but we need to change the top. So it's common top plus now energy bar height plus padding times 2. And then 100, and then energy bar height. And yes, we leave it an empty string so that a box is drawn, a gray box. So let's have a look at that. Common left plus padding, common top plus energy bar height. So if you remember up here, we have common top, which is equal to the screen.height divided by 2 plus 50. That's just positioning it from a certain height from the top of the screen that we wanted. All right, so yes, that looks about right. So we can go over here now, draw the health bar. So now it's draw the energy bar. And make its length be dependent on the player's current energy. So GUI.drawTexture new rect, common left plus padding, that stays the same. The common top bit needs to change. So now that's common top plus energy bar height plus padding times 2. And it'll now be energy bar length, because that's what we're drawing. Energy bar length. And energy bar height. And the texture to draw is energy text. Alright. And if you look at that top calculation, if you think about it, you'll see how it comes to provide the separation and the spacing that we want. So what it's doing is, what I'm doing here in this little calculation is just simply capturing, using that common top, the same one used by the health bar. So the same initial position from the top of the screen. And then I'm adding on the height of that energy bar. And then we also have this value called padding. So let's just go up. It's like spacing, really. That's all it is. Padding is equal to 10 pixels. So it's really just spacing. And I'm saying times 2. So that just brings it down just enough so that there's a space of padding between the energy bar and the health bar. And pretty much you'll figure that out by just trial and error when you need to determine the spacing of your own components. Alright, next we need to draw the GUI.label. So the label. So the common left plus gap stays the same as usual, but the common top needs to change. So it's common top plus energy bar height plus padding times 2. So padding times 2. Then the width is label width. The height is label height. And the value to show is not health for display. It's energy for display. .toString. And the style is energy style. Okay. So that should be it for our stat display script. Let's save it. And jump over to Unity. Let's go over to our players and attach the new script. So component, scripts, player energy, and the texture is needed here in our stat display. So let's give it the texture, energy bar texture. I'll just drag and drop it in. And now let's do the same for our red player. So go over to the red player, component, scripts, player energy. Alright, and then let's drop in that energy bar texture. Okay, and let's do a build and run. So file, build and run. Okay, I'll just set up a server, jump back here, connect as any player, and as we can see, we now have the energy bar. It's positioned correctly, and the figure displays there. But of course, at the moment, if we shoot or we blink, there's no effect on the energy bar. So that's our next 2 steps. Those are our next 2 steps, which is to edit the Fire Blaster script and the blink script so that they account for energy. So I'll just stop playing here. I'll just close that down and close this and move on to the next step. Okay, we're on to step 4, which is to update the Fire Blaster script. I have the Fire Blaster script open, and the first thing I'll write in the commentary is that this script accesses the player energy script. This script accesses the player energy script. And I'll go over to the player energy script and type in there that this script is accessed by the Fire Blaster script. And also right here in the meantime as well, that this script is accessed by the Blink script. Is accessed by the Blink script, which would be our last step in this video. So I'll just save that and jump over to the Fire Blaster script. Okay, so I need to add 2 new variables to our Fire Blaster script. I'll write the comment used in affecting the player's energy. And that is private player energy script, and then private float energy cost is equal to 10. And then we'll go over to the start function and access the energy script. So within here, so after accessing the spawn script, we'll say here, access the player energy script. So energy script is equal to my transform dot get component, and that component is player energy. Okay, so now we're accessing the script. So let's go over to the update function. Now what we'll do is inside this initial if statement, we'll add a bit about if the energy of that player is greater than the cost. So the player can only fire their blaster weapon when they have sufficient energy to do so. If their energy is less than the cost required to fire this weapon, then they can't fire it. So I'll just add a new bit here. So I'll write and go over to the next line, energy script dot energy is greater than or equal to energy cost. Okay, so that'll control whether the player can shoot their weapon or not based on how much energy they have. Okay, so right after this bit here, I'll add a new bit of code here to drain the player's energy. So drain the player's energy. And that's quite simply energy script dot energy is equal to energy script dot energy minus energy cost. And that's it. So that's all the changes we needed to make to this. So let's save the Fire Blaster script and let's just check quickly in Unity that no errors have been introduced, and no, they haven't. Alright, so we can move on to the next step. We're on to our last step, which is to update the Blink script. I have the Blink script open, and we'll do pretty much the same thing that we did for the Fire Blaster script. So in the commentary, I'll write, this script accesses the player energy script, and then we'll add some new variables. So going down to the end of the variables, we'll add use to affect energy, and they are private player energy script, private float energy cost, is equal to 35. And that's it for our variables. Now we can actually go over to the start function and access that energy script. So I'll just write here, energy script, or I just write the comment first, access the energy script. We'll access the player energy script, which is energy script is equal to my transform dot get component, and that component is player energy. Okay, so that's it for the start function. Now we'll go down to the update function, and the bit where we have blinking forwards, we only want to blink forward when the player has sufficient energy to do so. So we'll write here, and energy script dot energy is greater than or equal to energy cost. Okay, and let's just copy paste that little bit there and paste it down here for the blink back as well. So just pasted it in, and yes, okay. And then now the next line is to decrease the player's energy. So I'll write here, decrease the player's energy. So when they blink, their energy should decrease. So energy script dot energy is equal to energy script dot energy minus energy cost. And of course, we'll just copy paste that down below for backwards teleporting. And might as well get that comment as well. Alright, so that's it for our blink script. We can save it, head over to Unity. No errors have been thrown up. So let's build and run. So file, build and run. Set this one up as a server. Go back here. Connect, connect. So connect as a red team player. Alright, so our energy bar is showing. Let's fire. Yes, and we can see that the energy bar recharges over time, and it dropped in the first place when we fired our weapon. Alright, so let's keep firing away, and there we go. We can see that the rate of fire has decreased a lot, so it has to recharge in order for us to be able to fire our weapon. Alright, that's good. Now let's try and blink. Yes, so we can see that blinking uses up energy now, which is excellent. So we can't blink until, so no matter how much I hit the E key, until energy is greater than or equal to 35, I can't blink. Okay, and then the same behavior is for our backwards blinking. Let's check the blue player. So I'll connect again, connect, change to the blue team. Alright, so let's fire the weapon. Yes, same behavior. We can see that we're shooting, and it slows down when we don't have enough energy. Alright. Now let's blink. So yes, we drain energy and we can't blink until that energy recharges. Let's blink backwards. And yes, the behavior is as expected, which is good. Alright. So that is it for this video. We've implemented player energy. So now whenever we have energy weapons or energy behaviors, we will consume that energy to limit how much we can do them. So for our fire blaster weapon, we can't keep shooting endlessly. We now are limited, and we have to wait till our energy recharges. So that's pretty simple. This was a nice simple video as well. And in the next video, we're going to start implementing the construction block. And that's going to be a pretty big video. It's also quite interesting technically. The blocks themselves don't really have much value to this prototype game, I'd say, because we can only place several hundred. I'll talk about that in the next video, but all the details of how to place that block across the network and have the server control that behavior is quite interesting and quite important as well. So thank you for watching, and see you in the next video.